Hello viewers, in today's class we are going to discuss one important problem from limits, right? And here we have to evaluate the value of this limit where we have limit x tends to 1 positive and the function is the x times sine of a fractional part of x divided by x minus 1, right? So here the function involves the fractional part function, right? So we have x sine fractional part of x divided by x minus 1, right? And here this positive sign shows that we have to find the right hand limit of this function f of x when x approaches to 1 from the right of x is equal to 1, right? So we have to find the right hand limit. So let us call this limit as L, right? And here I will make use of the definition of fractional part function, right? So see, the fractional part of x is defined as x minus the greatest integer of x, right? So we can now write L is equal to limit x tends to 1 positive, and here we have x sine, and here we have x minus greatest integer of x divided by x minus 1, right? So now to evaluate this limit, what we will do, we'll make this substitution, that is x is equal to 1 plus h, right? So we'll take x is equal to 1 plus h, and here this point 1 plus h lies in the right neighborhood of x is equal to 1, right? So here this point is 1 plus h, where h is greater than 0 and h is infinitesimally very small, right? So when x tends to 1, then obviously h tends to 0. Right? So our aim is to convert this limit L in terms of h, right? By substituting x is equal to 1 plus h, right? So we have limit, now x tends to 1 plus or positive, we'll write h tends to 0, right? So when x tends to 1 here, h tends to 0. So now we have 1 plus h. Here we have 1 plus h, then we have sine, and for x we have 1 plus h minus greatest integer of 1 plus h, and here we have 1 plus h minus 1. Now let us simplify this expression. So we can now write L is equal to limit h tends to 0, and here we have 1 plus h, and here we have sine of 1 plus h minus greatest integer of 1 plus h, right? So let us first find out the value of greatest integer of 1 plus h. Now see, h is a very small quantity and it lies between 0 and 1, right? So 1 plus h is slightly greater than 1, but it is always less than 2, right? Now see, we have to find the greatest integer of 1 plus h, right? Now see, h is a very small quantity. So when h is added to 1, it will increase this 1 by a very small amount, right? So 1 plus h is slightly greater than 1, but it is less than 2. So the greatest integer of 1 plus h should be equal to 1, right? So here this quantity is 1. So here we'll write 1, right? And in the denominator, this 1 and this 1 get cancelled. So we are left with h. So now let us simplify it further. So we have limit here, limit h tends to 0. This is 1 plus h, and here we have 1 and 1 get cancelled. So we are left with simply h. So this is sine h, and here we have h, right? So now see, we have here sine h over h. So we can now write limit h tends to 0. This is 1 plus h times limit h tends to 0, and here we have sine h over h, right? So now this limit is 1 plus 0, right? Because here when h tends to 0, we'll take h is equal to 0, and here we have the well-known limit, that is the limit theta tends to 0, sine theta over theta is equal to 1, right? So the value of this limit is 1, so here we have 1, so L is equal to 1 plus 0 is 1, 1 into 1, 1, right? So the value of this limit is equal to 1. Now viewers, here it is very interesting to note that what will be the limit when we take x tends to 1 minus, right? So what would be the limit of this function when x approaches to 1 from the left of x is equal to 1, right? Or in other words, we can say that what would be the left hand limit of this function when x tends to 1, right? So this is left as an exercise for you.